So as you can see, this is a jar of highly discolored Lego. They were all white at the start. As you can see, some of them have undergone very significant damage, sun damage. Some are yellow, some are orange, some are even shades of brown. And this piece that I'm holding up here, right, this is the original white colored Lego piece. But it's all white, pure white. And I'm holding up here, a bit of it has undergone, can you see? Yep, this is shade of brown, right? Yes, that was exposure to sun, too much sunlight, discoloration. And here's a few more. Okay, varying degrees of damage by sun. Okay, the underside of this one again. Okay, wait for the camera to come into focus. The underside is all yellow. It's a bit off. Yes. Okay, there are some that are even worse. I'm going to show you right now. So look at this. This is supposed to be white in color. If you see me flip it on the side, right? Can you see it? It used to be white. Okay, but this is sun damage. Right. So putting it together, right? Okay, can you see the comparison? I stack it on top of my white plate. This is how badly some of my white color pieces have become. So why does this happen? Look at ABS as a whole. ABS, look at the full name on the screen, right? It is a polymer. You say long chain hydrocarbon. So in other words, it's also a plastic. It's considered a plastic. So due to the very nature of plastics, something happens. Photo degradation. So over time, prolonged exposure to UV light causes the polymer chains in the plastic to break down to form radicals. Okay, but wait, there's more. So another prevailing theory will have to do with the very structure of ABS in general. So back in the 90s, Lego bricks, we know they were made of ABS. And ABS, as a hydrocarbon, as a long chain hydrocarbon, is highly flammable. So we don't want it to be a fire hazard. So as with most plastic toy products at the time, right, many of them were sort of imbued with what we call BFR, brominated flame retardants. So they contain bromine that's supposed to help you prevent a fire, right? So over time, right, exposure to UV light, exposure to air, atmospheric oxygen could cause something to happen. But whatever it is, right, my Lego bricks will definitely start to become yellow. And the likely culprit is oxidation, probably. So we're not going to go into the concepts of thermal degradation, photodegradation, and all those high-level chemistry concepts related to polymers. So what I'm going to focus on today is what can I possibly do to help myself? Right? So a couple of years ago, a bunch of people online managed to decolor their yellow ABS products using hydrogen peroxide. Is that something? So that's what we're going to try today. So what do we need? Well, firstly, we need a transparent container, preferably made of glass. Okay, maybe some aluminum foil. Okay, that's not a reactant, don't worry. Okay, we also need hydrogen peroxide solution, H2O2. You can get this from the pharmacy, 3% is good enough. Okay, and probably we also need some detergent. Okay, in this case, right, I'm using Vanish because it contains this active ingredient. I hope you can see me zoom in here right about now. The active ingredient here is sodium carbonate peroxyhydrate. So this is just me carrying out the steps needed for me to prepare my experiment. Right, glass jar, foil underneath. I'm going to throw in some random yellow bits, yellow Lego pieces. Okay, you can see them here. They're all horribly yellowed to some extent. You can see it. Yep. So next I'm going to just put it down there. I'm going to add some H2O2 and I'm going to add some of my Vanish powder later. Okay, and we should be done. Okay. After this, we're going to do something else. We're going to move this downstairs. So over here, I'm in bright sunlight because I need sunlight for this thing to work. Okay. This is my Lego pieces. I'm going to cover it and I'm going to leave it out there for quite a while. Okay, so maybe a few hours. Let's see how it goes.
24 hours later.
Okay, so that took a little bit longer than expected. I changed my setup a little bit. I used tarp to cover it instead, so the H2O2 won't evaporate. So if you look at it now, right, 24 hours later, the next day, look at how much improvement the pieces have made. Okay? I mean, some of it's still yellowed. You can see there's still a little bit yellow, but it was much better than what they were before. Right, okay? I need to put a disclaimer that I did not swap out the pieces. These are the exact same pieces that I put in the day before. Okay, look, they are doing pretty well. Okay, some more pieces to show. Okay, so these are the pieces that are here after I washed them with water and dried them. Okay, because I couldn't handle them with my bare hands because H2O2 is not very safe to be handled with bare hands. So what exactly happened here? Well, there are a few theories. Okay, number one, peroxide managed to reduce bromine containing compounds. Okay. Or two, it managed to decompose the products of photooxidative degradation via reduction, perhaps. Okay, it's got to do with the polymer. Or number three, did the hydrogen peroxide manage to just bleach it? Right, that's the number one question, right? Did it just bleach? But whatever it is, right, I'm pretty happy with the results, because if you can see from my video, the exact same few pieces, right, different before and after. This difference is very significant. Our work is definitely not done, because more investigation is needed to find out exactly what my peroxide did to those Lego pieces, if it did anything at all. So remember these three prevailing theories. For the first one, that H2O2 managed to reduce any bromine or bromine containing compounds that came out. Okay, if it did, right, what are these products? Okay, what causes the yellow color? What are some compounds that could be produced? The second one, the H2O2 decomposed the products of photooxidative degradation via reduction or via oxidation, because remember, H2O2, right, can do both depending on the conditions. Okay, but then again, if you think about it, for polymer photodegradation, right, organic compounds, the reaction is usually quite irreversible because it's quite complicated. And not just that, the products of degradation become more brittle over time. So the structural integrity is also compromised. Is it the same for my Lego bricks? Okay, we could explore that. What about the third one? Did it just bleach the Lego? Okay, possibly. But if it did do that, right, perhaps I could even explore this with another household bleach. Could it work with, let's say, for example, any bleach that I get from my kitchen, maybe my Clorox, for instance? If the hydrogen peroxide was really acting as a bleach, okay, would it affect my colored pieces? Because Lego makes a lot of bricks in many colors. Would the peroxide treatment also cause these bricks to become discolored? Would they even become white? Okay, maybe even as an extension question, what did the sunlight do? Why must I expose my setup to sunlight in order for this whole thing to work? Could it also work in the dark? Well, in summary, we know that H2O2 definitely did something from a chemistry perspective to my Lego bricks. As we all know, hydrogen peroxide is a strong oxidizing agent, it is also a strong reducing agent, and it even has bleaching properties. More work needs to be done to investigate the kind of reactions that H2O2 was involved in with my polymers, with my ABS, or with the compounds within my Lego bricks. So this is just another example of how chemistry can be fun, right? I can use chemistry concepts to explain certain things and have certain applications. So maybe I'll do a follow-up video investigating other things related to my Lego bricks, right? So in the meantime, stay tuned for more videos and more content. Thanks for watching.